Hello everybody, this is David Anderson from Exact Engineering, and today I'm going to show you how we program parts using HSMWorks within SOLIDWORKS environment. The general philosophy is not to program on the actual part itself, but you program on a part or an assembly that is referencing the original part. And the reason why we do that, I think, will become evident, and hopefully you'll find this useful. Okay, so here we go. So first thing I'm going to do is I'm going to take this part here that I want to program, and I'm going to create a new part, and I'm going to use a template that I've created ahead of time, which has HSMWorks jobs already defined in it, and it also has HSMWorks features already defined in it. So if you're not familiar with template features in HSMWorks, you can go look it up. There's a lot of people that show how to do that on the internet. I mean, on YouTube. But essentially, you can save features that you've programmed and then bring them back into a program that you're creating. I've also created 6 jobs ahead of time, and these jobs were created ahead of time because of a couple things. The first thing is under the work coordinate system here, I always use Z and X axis. By default, HSMWorks always uses use origin and Z axis, and I don't believe there's a way to change this or make this a default way to use it. So the other thing is I always use a selected point, and this happens as default to the origin, but I don't use the model box point or stock box point. I don't find that helpful at all. So I end up using selected points. So I have that selected as well. The other thing is down here on the program name, I've pre-typed in the program name for each job. So as job 1001, the program name is 1001. And for job number 1002 is program name 1002. And so this would be setup 1, setup 2, setup 3, etc. So it just keeps things consistent as you go ahead and post out your programs. It makes things a lot easier also when you come back in to figure out which setup is which setup, etc. Okay, so I have a new part here, and I'm going to insert a part into a part. If you're not familiar how to do this, it's pretty straightforward. Insert part into part, and then I'm in SOLIDWORKS 2019, by the way. And so it's going to look at the open documents and say which ones you want to insert and what do you want to transfer. I basically leave the defaults. We want to transfer into solid bodies, axes, planes, cosmetic threads, sketches, etc. You can change this later. And then also, if you want to move the part around, sort of like an assembly where you can locate it by making a face coincident with a plane, etc., you can do that as well. And then this link, I always leave this unselected because I always want this part to link back to the original part. So I'm just going to accept the defaults, and I'm going to set the units of the drive part to the base part, and in we go. And down here, my units are inches, pounds. You see down here in the corner. Okay, so first things I want to do, a couple of things, is I want to create stock for this part. You can create stock in here using these features: relative box size, extrude a sketch. I don't like any of these, so I always create a solid. So it's very simple. I'm going to sketch on this face. Shift S in my system is sketch. N is look normal, and I'm going to offset 0.125. I find a 0.125 stock size offset is plenty if you're any good at using a saw, and that gives you enough material on the profile for a part like this. And I'm going to hit accept. Now we're going to be using 1/2 inch stock. This is a 3/8 thick part, so we're going to machine out a 1/2 inch stock. So what I'm going to do, I'm going to create a new solid and extrude it, and just instead of extruding it down 0.5 inches like this, I need some material on the top to extrude to account for the top face. I'm going to machine off. I'm not going to use the raw stock. I'm going to skim cut it. So I'm going to leave this set to 0.5 and deselect merge, so I create a multi-body part. And then where I'm going to extrude it from, I'm going to extrude it from an offset of 0.02 inches. Now I'm 20 thousandths above the part. See that? So now I have a 1/2 inch thick stock, and I've extruded it 20 thousandths. I started the extrusion 20 thousandths above the top of the stock. And I'm going to hit OK. Now, when I go to here, I have a solid model. And if I look now under my solid bodies, I have two bodies. I have the original part, and you can't tell, but that's the stock. They are not merged together. I'm going to go ahead and call this stock 1001, because that's stock for setup 1. And then I'm going to click on it and change its transparency. And now you can see we have two solids, and the part is within our solid body, which is the stock body. Okay? All right, so now a couple other things. I need to create a coordinate system, and we're going to go in here, right click and edit this. This is our setup. And first thing we're going to do is what are we machining? That's known as the model. I'm going to drop this down, and I'm going to go to solid bodies and grab it like this. And then the stock from solid, I can grab it here as well, or I could have clicked out in the window. Now, for Z-axis and X-axis. For Z-axis, I'm going to go off the front face of the part. You can see my Z is normal to the part. And then at X-axis, I always select these things. Just, you know, things change and things get flipped around, etc. So I always check these to preserve them as maybe the part changes. Then I'm gonna select the coordinate point, and I'm gonna use that vertex right there. Now I always put the coordinate system on the part. If for a couple of reasons, if you had to come back in and remachine a feature on this part after you took it out of the vise, your coordinate system, if it's on the stock, is no longer valid. And that's one reason. But the real reason I like to do it is my Z0 is at the top of the part right here. All machining is negative Z, okay? So if I'm proofing my part and I'm profiling the outside of this and I'm looking at the distance to go readout on my machining tool, and I see that I'm coming down, Z's 0.03, distance to go is 0.03 to 0. I know Z0 is going to be when the machine says Z0 on the part. I also know that when I'm machining down in depth that this part is 0.375 tall. So if I see my end mill going down minus 0.5, that should bother me, okay? So it's just another way to make things consistent. I always put the coordinate system on the part unless I'm using a fixture. If I'm using a machining fixture or like soft jaws, I put it on the soft jaws because I can always get back to those surfaces and pick up my coordinate system. Otherwise, I always put it on the part. That's how I, you know, some people do it differently, but I prefer to have it on the actual part because that's what really matters in the end. Okay, let's see. So now we have our coordinate system. We have our stock defined. Now I'm going to go in here and I'm going to now hide this stock, okay? I'm just going to hide it. So now I'm not seeing it. But one thing HSMWorks does do is when you click on the setup, it highlights the stock for you. So now I don't have to have that stock as a solid model. Now it's just a graphical representation. So let's see, some of the things we need to do. We need to face this. We need to do this inside pocket. And we need to do this, this outside frame here. So let's go ahead and look what we have saved here ahead of time. Let's see, I've got some facing going on. I have this 3-inch shell mill, so I'm going to Control C and then Control V. I'm copying things up versus if I drag them up, it would just move it from here up to here, and I would no longer have a copy of it anymore. So I'm just copying stuff, okay? So there's that. Let's see what this looks like. I'm not going to do anything. I'm just going to go generate toolpath and see what happens. Okay, it automatically figured out what size my part was because from the model selection and my stock size, and it created a toolpath. The other thing you'll notice is you'll never see any vertical lead-in radiuses on any of my toolpaths. I've been programming parts for 20 years. I don't know why all of a sudden we need these, but I find these extremely annoying as a default in HSMWorks. Machine tools can speed up and slow down on their own. We don't need a very complicated G code to get us down here. But the main point I don't like them is that when I'm proofing a program and I have a distance to go and I see the end mill up here, and the distance to go says 0.01 inches, and then it moves down a little bit because it's interpolating a radius. I find that extremely annoying and very unsettling. I don't know when I'm going to hit my Z0, so it really affects the distance to go. All right, so here's our part. We faced it off. Now we need to do the inside. So let's go ahead and I'm going to grab, let's see, this internal radius is down here, it's 0.27, so I can use a 1/2 inch end mill. I prefer using the largest end mill I can afford, mainly because it's stiffer and the material removal rates will be higher. So let's go down here. Now down here you can see I have, under my 1/2 inch, I have pocket, I have face, I have adaptive. These are all folders I've created for different feature types. And I have an adaptive blind and adaptive through. I'm going to use the adaptive through. And what the adaptive through has been pre-set up for is it allows you to grab the contour that you want to machine, and then it's going to go, it's already set up to go 20 thousandths steeper. See this from contour? So when I grab that contour like that, and I select machine cavities, the height is set to be from contour, and the stock to leave is 20 thousandths on the radius. Now I also could have put the stock to leave here and make this -20, and it would have gone -20 in Z. It's a couple different ways to do it. I prefer to do it this way. So let's see what it looks like. And there's our tool path. Okay, it's going to clear that pocket out. Now that we've cleared that pocket out, we need to do a contour on that pocket. So let's see what we have down here. So let's see, a 1/2 inch contour, contour through, Control C, and I'm going to paste it up into here, Control V. I'm going to grab this and edit this. I'm going to say OK. See how my speeds and feeds are all set? All this stuff is set ahead of time, okay? For a finished pass, that's a little fast. I'm going to make that 50. So everything's not perfect. Sometimes you got to fix stuff as you go along, but most of these settings are correct. So we're going to do a contour. I want to make sure I'm on the proper side of that. And while we're at it, let's do this one at the same time. Okay? Reverse that. Bang. Now we have two contours, and you can see they're going a little bit deeper than the part, because that's what you want. Because when we flip this over to deck the back side off, we don't want to try and meet up with the exact 3/8 of an inch deep. We want to go a little bit deeper so we have some wiggle room. Now the other thing we need to do is we need to put an adaptive on the outside, because I really don't want to finish 1/8 inch thick wall pass. So I'm going to take this and I'm going to duplicate this adaptive by Control D and edit this. We're going to get rid of that edge. I'm going to grab the outside edge. And the reason I have to do it twice, because machine cavities is selected. If I let machine cavities selected, it would machine on the inside, but I want it to machine on the outside, so that's why I have to do two different adaptives. And it's as simple as that. All right, let's take a look. Stock simulation. I'm just going to step through each feature. Face, inside, outside. You can see there's stock to leave, okay? Looks good. Oh, but the contours. Let's check the contours out. This contour. Let's see what this is doing here. Let's look at that again. Something looked like it didn't quite finish. Let's go all the way to the end. There's no material left there, but look at the corners here. See this material? This is something that happens a lot in HSMWorks that's going to bite you if you're not paying attention. And that is, there's this thing called minimum cutting radius. And there's a default based on a formula. It's like, I don't know, it's like 10% or something. So if I select here and I hit edit expression, yeah, tool diameter by 0.1. This is so that you don't do what, you bump into a corner, the old bump and run, and the end mill squeals. It's to keep the end mill always traveling and not stopping and then moving. So I'm going to go ahead and just make this 0. Okay? And so you'll see that it's going to get a little bit sharper. Now this is the 0.27 radius, so the end mill is not going to go in and ever stop, but now it's going to be able to go all the way into that corner because the radius was smaller than, there we go. You can see now that it's cleaned up. Okay? All right. So far, so good. So here we go. I'm going to save this as Control S. It's going to be Q 100-478-001 CNC. This way I know that this part is not a part that I'm going to be creating a detailed drawing of, etc., or putting in assembly. This is a CNC part, and it's for programming purposes only. All right, let's go back to our cam tree. So at this point, we've got the pocket done, the outside done, the top done. Now we need to add in a nice chamfer. I always chamfer my parts on the machine because they look so much better than doing it by hand, and it's so easy to do. So there we go. Right click the chamfer. I already had that saved. I'm going to go in here and I'm going to grab that and reverse it, and that edge, and reverse it, and hit OK. Okay. Did I do the outside of this thing? Yeah. Okay. All right. So now that I got those deburred, the other thing I was thinking about, these sharp corners here, when the end mill comes around here, it's going to leave a sharp corner, which is something that I'm going to have to deburr, which I really don't want to deburr. Okay. So I'm going to go in here and let's put a feature. Let's go ahead and put a fillet radius on here of 0.01, 10 thousandths. Just roll around that corner and wipe off any burrs. It's not going to affect the part at all, and it's actually going to make the part better. So there we go. There's the fillet radius. Okay. Let's see if we can generate our toolpath now. Uh-oh. Toolpath's not generating. Why is that? Well, the reason is we had a vertex here that we were creating, that we used to create, see, the job, or we created our coordinate system. See, the coordinate system is no longer, the geometry is no longer available. So what we got to do, we have to create some geometry here that we can use for our coordinate system. And one way to do that is to just grab the two edges like this. You go to Insert, Reference Geometry, Point. And now we have a point here, which is basically replaces that vertex. So I'm going to go into the feature tree, and you can see here's the fillet we added. Here's this point. I'm going to name this 1001. So I know that that is the origin for setup 1001. And now I'm going to go into here. I'm going to edit this, say yes. The only thing that's missing is the origin. So I'm going to drop this down, grab the point, and we're back in business. Here's something that's actually really cool too. As if you notice, even though I put fillet radiuses on here, if you notice, the contour is still good. And that's because when I selected the contour, all I did was grab one edge and I left this feature or this option turned on, which is tangent propagation and also propagate along Z. So if this is if tangent propagation isn't turned on, and propagate along Z it'll connect everything that's on the same Z. So leaving these both turned on ensures that if you do change the geometry, the contour should update and be valid. Okay, and everything looks good. So now if we go in and we say stock simulation, boom, all the way to the end, and there we go. Now we have these contoured or radius corners. I'm going to turn the material off. There you go. Now the chamfers here aren't really going to be exactly as represented. And the reason is because the chamfer tools, they don't have perfectly sharp points on them. So depending on your chamfer tool, it may have a bigger chisel point on it or a smaller chisel point on it than is represented in the actual cam package. So that's something that you're going to have to go determine on your own. And actually, like how much chamfer do you get when the tool tip is at Z0? Because they will often cut deeper, maybe because there is a chisel point there. Okay. All right, so now what we need to do is drill and tap. And let's see, we need to do some M4s. So I happen to have M4 form tap right here. I'm going to take this, Control C, and Control V and copy it up like that. Okay. And then right in here, I have the tap, I have the spot drill, I have a tap drill, and I have a tap already predefined. And the nice thing about doing it this way is that I've already determined by using the spot drill, I'm going to select same diameter, it selects them all, boom, it's done. And then I'm going to grab it. Now this, I know that this spot drill, this 1/4" spot drill, I have selected the depth such that it's going to give me the proper chamfer so that when I thread this, I don't have to go back and chamfer the thread afterwards. The reason you don't want to do that is if you chamfer your threads after you've cut them, you drive chips down into the hole and it makes screws hard to start, especially if you're working in steels. So I always chamfer the first and then I tap. So, and because we're using a form tap, we want to chamfer a little bit more than we were for a cut tap because you get a bulge on the first thread. All right, so I know that this spot drill is going to give me the right depth. And then here we go. I'm going to grab this. Sure would be nice if you could just grab these holes once and apply all the operations to those holes. But HSMWorks doesn't let you do that. Other packages like BobCam and stuff do. I don't know why they don't do that. But this is, it'd be nice if I just select these holes once and apply all the threading operations to them. Maybe they'll do that. You listening, HSMWorks? Okay. So what I want to do, I want this drill to go all the way through. Okay. And right now it's selected from hole bottom, and it's saying drill tip through bottom, and that's fine. But I want to go through the stock. So I'm going to go from stock bottom, like that, and I say drill tip through the stock bottom. Okay. That's going to just barely get us through the stock bottom. But I'm going to go a little bit further, so 0.03 to make sure that we do break through. All right, now I'm using a form tap, which we always form tap everything in aluminum and some steels. We try to form tap everything, and the reason is form taps don't leave chips. They give you a stronger thread, and they don't break as easy, but if they do break, they're impossible to get out without burning them out. So drawbacks to everything. All right, so I'm gonna grab these holes again, grab that same hole, select same diameter. Now I want this tap to go through, so I'm gonna change the height to be from model bottom or hole bottom, it's the same thing, and I'm gonna go drill tip through bottom and like this, okay? 0.1 should give me enough thread. I'm using a bottom style M4 form tap. That should get the tap all the way through without leaving an imperfect thread on the bottom. Because we want to be able to access the threads from both sides on this part. Okay, that's the M4. Now let's see what we have for 1/4-20. English tap. I only happen to have a 1/4-20 cut tap, and I want to do a form tap. So I'm going to go out to my library, create from template. Oh, there we got one right there. I'm going to create all templates. So I'm using a 3/8 spot drill this time to spot the 1/4-20, because you have to use a bigger spot drill than the tap hole that you're making if you want the chamfer to be bigger. I'll use a 228. grab those guys. Okay, and one more. Those guys. Okay, so the top of this part is effectively done. Stock simulation. I'm going to turn off the part. See, we got some nice chamfers around our tapped holes. Part looks good. 26 minutes I've been programming this part in front of you. Not too bad. Now, if I wasn't talking you guys through this, I probably could do it in about half the time. All right, so we need to do the back side. So at our company, we always rotate about the x-axis. Okay, so there's the negative rotation about the x-axis, and our new coordinate system is going to be right here. I'm going to grab those two edges, insert, reference geometry, point. Boom. While I'm at it, I'm going to go into the feature tree, 1002. That way, I don't forget to do it. And I also, down the road, when someone comes in to look at this and tries to figure out what all these features are, you know, all these features here, what are they? Okay. Well, we know that that's the coordinate system from 1001 and 1002. So now we want to go in here, and I'm going to set up number 2. This is setup number 2. Edit the model. I'm going to go in here. Well, I'm just going to grab that. And then for the solid, because it's not showing the stock, I'm going to grab that. Now, I could go in and make a stock shape that has a top hat on it, but there's really not any value added to doing that. So we're just going to go ahead and do it like this. And then as far as our x-axis, we want to grab that. I didn't change the front there, and now we got that right. I want to reverse our x-axis. Wait a minute, that's Z. There we go. And then we're going to change our point to be there. Okay, there's that. Now we need to get rid of this top hat that's going to be on here, and then we're going to go in and we want to do some chamfering. Now we could just go in and try and face this slug off here. But one of the things that happens is when you have an open hole like this or a pocket and you're running a face mill across it, you don't want to take it all off at once because you're going to get a terrible finish. But if you try to skim it down, you can end up with a slug of material in here that falls out and gets caught. So we don't want to do that. So we're going to go ahead and remove this material with an end mill first, and then we'll finish it with a face mill. So I'm going to go in here, and we have pocket. Or I can go in here and go adaptive. We're already using our 1/2 inch tool. So let's do an adaptive through. I'm going to go in here. Place this. I'm going to edit this. And we're going to grab this contour here. We're going to select machine cavities. We want it to 20,000 stock to leave is fine. We don't want to try to machine up to the edge. We want to do a helix. Okay? And a 5-degree helix is fine. And now it's going to helical down in and get rid of that material so we don't have a problem with a slug. And you can see that it is machining below the surface. I'm going to pass it a little bit deeper. Move the end mill, you know, maybe let's go 0.2, okay? Whoops, sorry. -0.2. This gets the end mill down in, let's go in 25. All right. This way I'm not using the very tip of the end mill to do this. Don't want to wear that out. Plus it's going to be stiffer. So there we go. It's going to clean that out for us. And what it's going to leave a little rim all the way around. And that I'm not that worried about, but that big slug falling out could be a nightmare. Now that that's done, let's grab our face mill, which is up here. Control C, Control V. Going to edit this, and we're going to have this go multiple depths. And it already is 0.1. So let's see, and there we go. Okay. Control S for save. Now we need to go in and do some chamfering. I'm going to grab our chamfer tool, cut and paste, edit. have to go in here and remove these, and we're going to go ahead and grab that, reverse, that, reverse. We can even come in and do these. It always puts the arrow on the wrong side. If anybody of you know a way to stop that from happening, please let me know, because it's pretty annoying. Okay. Now, it didn't do the small holes because there's a lead in and lead out. And I would have to just go in and change that. You can see the lead in and lead out here. See that? If I got rid of that and made that 0, then it would actually go in and do those holes. So what I'm going to do, I'm going to leave those the way they are. And I'm going to duplicate this. And I'm going to come in and edit here. And I'm going to go in and remove these holes, like so. Then I'm going to go edit these holes, and we're going to go get rid of that, 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 keep that, get rid of that, keep that, get rid of that. And then I'm going to go here to lead in, lead out, and we're going to turn it off. Whoops. Now we'll chamfer those for us. All right. So hands-off machining, everything's done. It comes off the machine. It's going to be good to go. Let's go ahead and simulate these guys. I'm going to go right to the very end. Turn off the part so we see what the machining process looks like. And there you go. And the reason these holes look so much bigger is it's not drawing into threads, it's drawing in the major diameter, so they look a lot bigger than they're actually going to be represented. You can see they're drawing the same size as the thread there. All right, we have 2 more setups. Okay, Control S. Save early, save often. Now, we have this setup over here, and that one there. So we're going to take this, rotate about to X. We want to grab this now. So I know I need a coordinate system here. I'm going to show you another way we can create a coordinate system when you have a radius corner here. So I'm going to grab that edge, grab that face, insert, reference geometry, point. There's a vertex that we can now use for that to put a coordinate system there for 1003. Let's go down and change this to be 1003. And I'm going to edit this. And I'm going to go in and for my model, we want to grab that. And this time for my solid, I'm going to say relative size box. You know, I don't really care about having any other features on here. I'm going to use the basic, you know, I'm just drilling and tapping a small hole on one side. So here, so I'm going to change my Z there. Make sure I select my X. My point for the origin, I want it to be 10 quarter 20. Drill and tap. This, this, and this. Control C. Control V. Edit. Okay. Again, would it be nice if they could cluster all these into one feature, so that you don't have to keep selecting the same feature 3 times just to drill? I mean, this is kind of ridiculous. Yeah, why am I selecting this hole 3 times when all these features are acting on that hole? I don't know. That's how it does it. So there's that. Okay. So there's that setup. So you can see it's going to create a stock around this whole thing, and that's good enough for what we're doing. Now we need to do this end. So I'm going to stand it up like this, and we need another coordinate system. So I'm going to grab this edge and that face, insert, reference geometry point. That's setup 4. 1004. Go back into CAM, go down to here. I'm going to edit this. The model's that. This is going to be relative size box. There's our Z, is that face. Here's our X. And our origin is going to be 1004. Control S, save early, save often. I'm going to grab these three, drill and tap, go down to 1004, edit. So, you know, these types of things where you're doing the same thing over and over, you know, this is what computers are great for. And God, I would hope that, you know, they would, you know, the programmers would be like, geez, you know what? How do we minimize the bookkeeping that our users have to go through? Let's see this hole. Now let's see what's the depth of this hole. That's from hole bottom. We want the drill tip to go through the bottom. Okay. Let's do that. That reminds me, we should check this one. What is this one doing? Yeah, we want to check this one, have it go through the bottom. Yeah, 0.1's enough. Okay. Yep. Okay. Just select this one more time. And go here, and we want this to go through the whole bottom. That should be plenty, like so. Okay. Oh, there you go. This should be the whole part, all programmed in 38 minutes and 35 seconds. Now, it doesn't mean I'm done. It means I've programmed it and I need to go in and check everything, double check everything, so I'm not making 5 trips to the machine. No, let's generate the toolpaths. Just have them regenerate them all. Oh, still waiting, I guess. There we go. Let's just hit them all. Turn off the part itself. All right. We chamfered everything. Looks like we have. So that's the part. Now at this point, I likely don't need all these other features. So one of the drawbacks of creating this is if I go into tool library, look at all the tools that are in here. Okay. These are tools that are all predefined, and so we don't need these. So what I do is I click on features and I hit delete. Now they're gone. And I can go in here and delete these 2 setups because I know I only need 4 setups. I can delete those. Then if I go to tool library, I can go in here and say remove unused tools, and it removes those. And now it's cleaned up. Now I'm ready to post-process this part. Okay, just gonna do a few more checks, final checks to make sure that this part is fully machined. And then we will send it out to the post-processor, to the machine. And I will go ahead and add a little sped up by 5x video clip of the part being machined. Okay, here's a picture of the final part. This is showing the backside that I machined off, and although I did run the chamfer around those holes, you can still see I need to do a little bit of finishing on the chamfers. But other than that, this part's a wrap. Thank you guys so much for watching. I really appreciate it. My hope is I can put more videos out like this, so please do subscribe and hit that like button if you enjoyed this video. We'll see you next time. Thank you.